Microbiologically influenced corrosion, or commonly also called as MIC. The hidden threat to industrial integrity. Here also we'll talk about impact of microorganisms on industrial material durability. Introduction. What is MIC? Corrosion is a natural process that affects metals over time, but microbiologically influenced corrosion, or MIC, stands out because it is accelerated by microorganisms. Unlike traditional corrosion, MIC involves complex biological and chemical interactions that make it harder to predict and control. MIC is often overlooked in industrial maintenance strategies, yet its impact can be catastrophic. Understanding MIC is essential because it compromises structural integrity, increases operational costs, and poses environmental and safety risks. This introduction sets the stage for why MIC deserves attention from engineers, managers, and policymakers. MIC occurs when microorganisms such as bacteria interact with metal surfaces, creating localized corrosion. These microbes form biofilms that alter electrochemical conditions, accelerating metal degradation. MIC is commonly found in pipelines, storage tanks, and marine structures where moisture and nutrients support microbial growth. Unlike uniform corrosion, MIC often leads to pitting and underdeposit corrosion, which can cause sudden failures. Understanding MIC requires knowledge of microbiology, chemistry, and material science, making it a multidisciplinary challenge for industries worldwide. How MIC occurs: industries at risk. MIC begins when microbes attach to metal surfaces and form biofilms. These biofilms create microenvironments that differ significantly from the surrounding fluid, altering pH and oxygen levels. Sulfate-reducing bacteria, for example, produce hydrogen sulfide, which reacts with metal to form corrosive compounds. Acid-producing bacteria lower pH, accelerating corrosion. These localized changes lead to electrochemical reactions that damage the metal faster than normal corrosion processes. MIC is particularly aggressive because it combines biological activity with chemical attack, making prevention and detection challenging. Industries most affected by MIC include oil and gas, water treatment, marine transportation, and power generation. In oil and gas, MIC can cause pipeline leaks, leading to environmental disasters and costly repairs. Water treatment facilities face MIC in storage tanks and distribution systems, risking contamination. Marine structures such as ships and offshore platforms are vulnerable due to constant exposure to seawater and microbial activity. Power plants experience MIC in cooling systems, which can disrupt operations. These sectors face billions in losses annually due to MIC-related failures. Global impact, signs and detection. MIC costs industries billions of dollars annually in repairs, downtime, and environmental cleanup. Failures caused by MIC can lead to catastrophic consequences, including oil spills, water contamination, and structural collapses. Beyond financial losses, MIC poses serious safety risks to workers and communities. Regulatory penalties and reputational damage further amplify the impact. Addressing MIC is not just an engineering challenge but a business imperative. Investing in prevention and monitoring can save millions and protect lives. Detecting MIC is challenging because visual signs often appear late, when damage is severe. Common indicators include pitting, discoloration, and unexpected leaks. Advanced detection methods involve biological sampling to identify microbial species and electrochemical sensors to monitor corrosion rates. Predictive analytics using real-time data can help anticipate MIC before failures occur. Early detection is critical for implementing timely interventions and avoiding costly repairs. Prevention strategies, monitoring and control. Preventing MIC requires a combination of strategies. Material selection is crucial. Using alloys resistant to microbial attack can reduce risk. Biocide treatments help control microbial growth in pipelines and tanks. Protective coatings create barriers against biofilm formation. Cathodic protection systems prevent electrochemical reactions that lead to corrosion. These measures must be integrated into maintenance programs to ensure long-term effectiveness. Monitoring MIC involves regular inspections and advanced technologies. Predictive maintenance using data analytics can identify patterns and forecast potential failures. Smart sensors provide real-time data on microbial activity and corrosion rates. Combining these tools with proactive maintenance schedules ensures that MIC risks are minimized. Continuous monitoring is essential for industries where downtime and failures have severe consequences. Future trends, real-life case study. The future of MIC management lies in technology. Smart sensors capable of detecting microbial activity in real time are becoming more affordable and reliable. AI-driven predictive models can analyze large datasets to forecast MIC risks accurately. These innovations will enable industries to shift from reactive to proactive maintenance, reducing costs and improving safety. Embracing these technologies is essential for staying ahead of MIC challenges. A notable case involved a pipeline failure in the oil and gas industry due to MIC. The failure led to significant environmental damage and millions in repair costs. Investigations revealed inadequate monitoring and lack of preventive measures. This case underscores the importance of proactive MIC management and the consequences of neglecting this hidden threat. Environmental impact, safety implications. MIC-related failures can lead to leaks that contaminate soil and water, harming ecosystems and communities. Oil spills and chemical leaks caused by MIC pose long-term environmental challenges. Cleanup efforts are costly and often fail to restore ecosystems fully. Preventing MIC is not just an economic necessity but an environmental responsibility. MIC compromises structural integrity, creating hazards for workers and the public. Failures in pipelines or storage tanks can lead to explosions, fires, and toxic exposure. Regulatory compliance requires industries to manage MIC effectively to avoid legal consequences. Safety must be a top priority in MIC management strategies. Summary, call to action. MIC is a costly, dangerous, and preventable problem. It accelerates corrosion, threatens safety, and causes environmental harm. Awareness and proactive measures, including prevention, monitoring, and adoption of new technologies, are essential for managing MIC effectively. Industries must prioritize MIC management by investing in prevention strategies, monitoring systems, and innovative technologies. Collaboration among engineers, microbiologists, and decision-makers is key to reducing MIC risks and ensuring operational safety and sustainability.